Hello everybody, this is review number 2 for chapter 4. Miguel and Molly are cyclists. The graph shows the distance that Miguel biked one day. Molly biked at a rate of 0.15 of a mile per minute. Which statement about their speeds is true? So if we're looking for speed, they're all talking about speed, right? That's speed, 2.2 miles per minute, 0.5 or 5 miles per minute. Those are all speeds. Speed is a rate, which is the slope. So we're looking for the slope. And we're comparing two different things. We're comparing Miguel and Molly. Well, it says Miguel, his information is in the graph. It says the graph shows his distance. So we can label the graph Miguel. And we know Molly biked at a rate of 0.15 of a mile per minute. So Molly is this, where this is our slope. Y equals mx. That's our slope. They don't say anything else about it, so there's no b. We're just worried about the m, the slope. So we can find the slope of Miguel. We can find the slope of this graph by finding the rise over run. So remember, the slope is the change in y, the rise, over the change in x, the run. So if we use these 2 points, we are going to be going up. How many? We're going to count. Well, from 6 to 9 is how many I'm going up, right? I'm going up by 3. And then I need to run over. I'm just looking at the x-axis here. I'm going over from 15 over to 30. That's a difference of 15. And you notice that the line is going uphill, so we know it's positive. Change in y is the rise, which is 3, over the run, which is 15. And since Molly's slope is in decimal form, I'm going to go ahead and change this to a decimal as well. Just divide 3 by 15. On your calculator, 3 divided by 15 is 0.20. So then our equation for Miguel, if you want, we can write that. Y equals mx, so 0.20 x plus the b in this case. Since it is a graph, I can read the b. It's where it hits the y-axis. It's plus 3. We're not really worried about that right now. We're worried about the slope. We're comparing the slopes. So I'm going to highlight them. Okay, so those are the two things we're comparing. So, A, is Molly's speed, here's Molly, is Molly's speed the same as Miguel's speed, which is right here? Obviously not. 15.15 is not the same as 0.20. It's not A. Was Molly's speed greater? Well, you know that 0.15 is less than 0.2, so it's not that either. Did Miguel travel 0.2 miles per minute, 0.2 of a mile per minute? Yes, 0.20 is the same as 0.2. Okay, so that is our answer for number 1. Okay, number 2. What is f of 3 if f of x is negative 4x plus 1? We're going to go ahead and plug in 3 for x. So f of 3 will equal negative 4x plus 1. Let's rewrite this, plugging in 3. There was my x. I plugged in 3 instead. And we're going to simplify. Negative 4 times 3 is negative 12. And we're going to add 1. So f of 3 is negative 11. All I'm really interested in is that. As long as you can get that, that's fine. Some people also write it as an ordered pair, meaning the x comma the y. What was the x that we plugged in? We plugged in 3. And what was the y? The stuff we got out, that was a negative 11. Either answer is fine. Number 3, which table represents a non-linear function? So this time, we want something that doesn't have the same slope. Not the same slope. If you remember on review number 1, we wanted to find a linear function, so we wanted to find the one that does have the same slope. This one, we want the one that doesn't. So let's look at A. Let's first remember what slope is. It's the change in y over the change in x. We've done that a bazillion times. So what's the change in y for A? The change in y is adding 2, so positive 2, over the change in x, that's adding 1. So the slope for the first part of A is 2 over 1. Over here we also have plus 2, and we also have plus 1. So far they are the same. If you look here, 2 over 1 is the same as 2 over 1. And then we do the next one. You always have to check all of them. We're also adding 1 and adding 2 here. So again, they're all the same. So this one is linear, and that's not what we're looking for. So we know it's not A. Let's do B. Okay, so we have the change in y. That's getting bigger. So we're adding 2 over the change in x. I'm going to do it down here a little bit so you can fit it. From 5 to 9, we're adding 4. So the change in y over change in x is 2 over 4. Let's try the next one. Again, we're going to add 2. And again, we add 4. That's the same so far. And again, we add 2. And we add 4. So if you notice here, all of the y over x's are the same, right? So that one is also linear. Okay, let's work on the next one. I'm going to just write an L for linear. C. Let's get change in y, add 2, change in x, add 5. Let's do it again. Change in y, add 4, change in x, add 5. So as you can see right here, 2 over 5 does not equal 4 over 5. So this one is not linear. And that's what we want. We want the non-linear function. So it's answer C. Write the equation graphed at the right in slope-intercept form. So of course we want y equals mx plus b, where we need to find m and b. If we find m first, m, of course, is again the change in y over the change in x. The change in y, if I take any 2 points, I'm going to go like this. Doesn't matter which 2 you use. I'm going to rise up 1 and run over 2. Rise over 1 says 1 over 2. Simplify it if you need to. That one is already simplified. Let's find b. B is the y intercept. Where does it hit the y axis? Okay, right here. It hits at 1, 2. So B is 2. Okay, I'm going to draw an arrow there in case you need to see it later. I'll draw an arrow here so you see how you got that one. All right, so we have our n, which is 1/2, our b, which is 2, and we just write it out. Y equals 1/2 x plus 2. Number 5, which function matches the function table at the right? So this one you have to actually find m and b from the table. M is the easy one. Still change in y over change in x from a table. Add 3, negative 2 to 1. You got to add 2 to get to 0 and 1 more to get to 1, so that's also adding 3. So it's 3 on the y side over 3 from the x side, and that equals 1. So our slope is 1. And we can do this multiple ways from this point. I'm going to keep continuing to do what we've been doing in class, using y minus y1 equals m times x minus x1. And then we'll rearrange it. So use any 2 points you want. I think on my review online I used 1 and 3. Today let's use 5 and 7. It doesn't matter which numbers we use as long as they correspond with each other. So for the y, of course this is y. Y is going to be 7. So it's y minus y1, which is 7, equals m right here, which is equals 1 times x minus right here, 5. And we'll rearrange that one. Of course, 1 times anything is itself, so that one's easy. Y minus 7 equals 1x minus 5. I did multiply 1 times a negative 5. And then lastly, we'll rearrange by adding 7 to both sides to get y equals 1x, which is also just x, and a negative 5 plus 7 is plus 2. So that's our answer. Just find the one that says that, which is this one. Of course, you know f of x is the same as y. Graphs that represent situations that may not have numerical values are our qualitative graphs. They're called qualitative. Linear just means it's straight. Nonlinear means it's not straight. And quadratic looks like that. Number 7, a plant is a certain height. The height of the plant is measured for several weeks. The graph shows the height of the plant for each week. Which statement is true? Well, let's look at our statements first to see what they're looking for. A says the plant grew 2 inches per week. We know that keyword means we're looking for slope, so is the slope 2. B says the same thing. Slope is the slope 0.5. So again, this is M. Then C and D talk about the initial height, which is the y-intercept. So they're asking for the y-intercept. So let's find the slope and the y-intercept of this graph, and then we'll figure out which answer is true. So we have 2 points. You can write down the points and use the slope formula if you'd like. I'm just going to use the graph. So I'm going to do my rise, which is the change in y, over run, which is the change in x. Okay, so I'm rising up from 4 to 6 is 2. And I'm going to run over from 2 to 6, which is 4. Rise over run, so 2 over 4, which reduces to 1/2. So our slope is 1/2. Let's write it as a decimal as well. 1 divided by 2 is 0.5. All right, and you could use that big formula to find out B, but watch this. Every time we know it goes down 1, left 2, down 1, left 2. Guess what? Down 1, left 2 brings us to our y-intercept of 3. So we have y equals 0.5x, or 1/2x, that's the same thing, plus that y-intercept of 3. So this is M, this is B. The only one that's correct, obviously M is not 2, and we know the height isn't 2, the B isn't 2, the B isn't 4. The only one that makes sense is this one. Domain, easy one, all the x's in numerical order. So the domain is -2, comma 0, comma 1, comma 3. Range would be all the y's. This one gives you some extra information. So let's just read this. Student tickets cost $6.50 each. And adult tickets cost $9.50 each. Which equation could be used to find the total cost C of any number of student tickets T? And I'm going to underline this. Remember, when it asks you to find something, that's what you start with, right? Total cost C, finding C. So we're starting with C equals. And what are we looking for? We're buying any number of student tickets. Well, the student tickets cost $6.50 each, so the only one that starts with C and has a $6.50 in it is B. All right, Beth's monthly charge for internet access C is represented by the function C equals 12 plus 250H, where H represents the number of hours of usage during the month. What is the total cost? So what is C for a month in which Beth used the internet for 9 hours, 9H. So we're just going to write this formula down. 12 plus 250H. And we're looking for C when H is 9. We're going to use our calculator. Go ahead, you can do the multiplication first. So this is still going to be C equals 12 plus something. 12 plus, well, 250 times 9, I get 22.5. And then when we add 12 plus 22.5, we get 34.5, which is also 3450, which is answer D. And the last one, the graph shows the amount of food Dan's bobwhite quails eat each week. Which equation can be used to find the number of pounds Y eaten after any number of weeks X? So if you look at all these, none of them have a y-intercept. It's all y equals mx, y equals mx, y equals mx, y equals mx. So no B. All you have to do is find the slope of this graph. The slope can be found many ways. You can do rise over run. I'm going to do it this time using the first 2 points. So the first point is 1,75. Second point is 2, 150. I'm going to label these. This is x1 and y1 because it's my first point. And then this is x2, y2 because it's my second point. And we know the slope formula is y2 minus y1 over x2 minus x1, and then you just plug it in. Y2 is 150 minus y1, which is 75, over x2, which is 2, minus x1, which is 1. 150 minus 75 is 75. 2 minus 1 is 1. So this is just 75. So that's our slope. Y equals mx, which is answer 9. Follow instructions in Google Classroom for any additional information.